just may have to happen. So we have a lot of objectives here. You know, we've got understand the restricted domains and ranges of inverse trait functions. We talked about that yesterday. Like I said, I wanted to get you a heads up on thinking about that open the door piece, you know, that we've got sine, cosine, and tangent to think about those principal value ranges. And then evaluate the inverse trait functions. We're well on our way there. We've gotten a really good start. Compose the trait functions and inverse trait functions. Probably not until our 2-hour release schedule tomorrow, our little half-hour classes. And then apply inverse trait functions. Absolutely, absolutely. We're on the way there. So those were our objectives, and we got to the bottom of the section. Okay. And now we need to use a calculator. So is there anybody that needs to borrow one today? Uh-oh. Did it take a fall? Yeah. Let's go with one that works for sure. Okay, so this just says, hey, you know what? Let's use a calculator. And you look at this and you say, I don't know what that is. You know, I don't recognize negative 0.81 as something out of my special triangles. So what we have to do is follow the directions like it says. And this is, it's one of those things that when you get the test, you have to read each question carefully. And before you grab your calculator, you have to say, do I have this in the right mode? Because that's going to make all the difference in your answers. So use it in the radians mode. Radians is already darkened on mine. And then I need inverse sine. So second function sine, negative 0.81. And there it is. And we round the 2 decimal places. So negative 0.944. Second one is a little more challenging. So let's see. Second inverse sine of 3.49 second pi, parentheses, enter. Negative 1.539. Yeah. So now, my follow-up question is, why isn't that 3.49 pi? I mean, shouldn't we just get 3.49 times pi? Why on earth would that possibly change to negative 1.539? Think about what we did yesterday. What did our answers have to be in? Where did they have to be located? The PBR. Bless you. So this is one where I'm going to take this a little bit further, and we're going to actually draw this one and see why did it end up the way that it ended up, you know? Because, yeah, once you get that answer, you're like, wait a second, doesn't inverse sine and sine, don't they cancel each other out if you're in the PBR? So I start thinking 3.49 pi. There's 1, there's 2, there's 3. So I'd have to go another, not quite halfway, so 0.49 pi this way. That's not in the PBR. Where's the PBR for sine? Over here, right here. So then we have to think, okay, so whatever sine functions are going to do over here, we have to make sure that we are going to get the same positive or negative value in the PBR. So in third quadrant, sine positive or negative? Are you going through this thing in your head right now? It's negative. So we would have to place that in fourth quadrant in order to get the same values. And then you think, well, place what? Well, 0.49 pi over here. And then, we talked about this yesterday, but I want to explain it another way. One of the things you have to do when you are naming these, when you're giving them their value for your final answer, is you can't leave the PBR. So we can't look at this and say, okay, let's start right here and let's go all the way around. We have to think, I have to stay in the PBR to name this, so this will be my positives and this will be my negatives. Negative 0.49 pi. Now let's check. Does that match? Negative 1.539. Negative 0.49 times pi. There it is. So it was about being in that principal value range that made that work the way that it did. So it's not as simple as just looking up and saying, hey, this is sine and this is inverse sine. Boom, we're done. Write down 3.49 pi. That's not as simple as that. We have to make sure we're in the PBR. So that's where we're thinking as we go on. And now we're going to talk inverse cosine. So inverse cosine, we want to do the same thing. We want to see a sketch of the graph, and we want to figure out what's a convenient, great way to get a little one-to-one function from cosine. So with cosine, you remember it was 2 pi for the whole period. We divided it into 4 equal chunks, and those were pi over 2 chunks. Forwards and backwards. Oh yeah, I might have a nice headache by the end of the day. That is really super bright. And we know it went from negative 1 to 1. Where's that stuff? Oh, Kahala. Pi, axis, low, axis, pi, and backwards. So the whole reason we were doing the PBR thing is because what we have to do is make sure these functions are one-to-one. Because calculus works great when things are one-to-one. For every input, exactly one output. For every output, exactly one input. And I start thinking, well, that means I have to go from negative 1 to 1. But this is kind of out here in no man's land. There wouldn't be horrible, but it's negatives. Well, this would be kind of nice. It's right there. It's got everything I need. Here. Here. And it's positives. That's always great. So I think about what interval that is, and I realize that what we're doing is we're going from 0 to pi with cosine. So again, we think about that motion of opening the door. We had cosine, negative pi over 2 to pi over 2, turn it to open it, and now we've got cosine. And that's going to be from 0 to pi, which makes perfect sense. So like we did yesterday, if we want to get a little sketch of this bugger, we're going to need to write down some ordered pairs. And then we have to switch them around, because that's what inverses do. So I look at this and I think, well, you guys told me to graph that. Go up 1 before I start. And then I can see that if I go out pi over 2, then I'm at 0. And if I went out to pi, I was at negative 1. So to sketch the graph the inverse, all you do is you switch the x's and the y's. So let me switch colors here and switch the order. Realize, well, now my domain, my x's, are what's going from negative 1 to 1. But my y's is going to be 0, pi over 2, and pi. And I need to get those points on there. So 1, 0, 0 pi over 2, negative 1 pi. And then, like I said yesterday, I mean, we could sit and be really nitpicky and say, okay, what was it for 30 degrees and change that into pi over 6 and find where there are. But for what we need to know, all you need to know is it kind of curves like that a little bit. Like so. Because what we really wanted to see was, what should we use? What should we use to make sure that we're going to have a one-to-one function? And that's going to happen up here. cosine. So when we think about our PBR for cosine, so our domain is still going to be from -1 to 1 for our inverse. But unlike sine, this one is going to go from 0 to pi. So when you do this, you need to think, okay, gotta be in the PBR, gotta be in the PBR. This one is 0 to pi. And go through that. So down here it says the inverse cosine function is the function f of x equals the inverse cosine of x with a domain from -1 to 1 and a principal value range from 0 to pi. This means that x represents a cosine ratio, f of x represents some positive angle, and either acute or obtuse in either quadrants 1 or 2. The inverse cosine function is also called arc cosine, so they mean the same thing. Like I said, it's that whole -1 that looks like a power thing that messes with some students, and we just have to know it's the same thing, it's just notation. That's all it is. So denoted by f of x equals arc cosine of x. Inverse cosine of x, angle between, what's our PBR? There we go, yeah. 0 to pi, whose cosine is x. So we're looking for that angle. That's what we're looking for. Well, look at that, we're already two examples. Evaluating inverse trig functions without a calculator. All right, so getting into the brain, I need to be thinking 30, 60, 90, 45, 45, 90, or they wouldn't tell me without a calculator. Inverse cosine, all right. So I need inverse cosine. Just got a new PBR. And I look at -square root of 2 over 2, and I remember, wait a minute, but that's not how that starts. Because that starts as -1 over the square root of 2, and then we have to rationalize the denominator. So probably better to think of that as -1 over the square root of 2. And then it's negative. Okay, well, I'm restricted with my PBR to either first quadrant or second quadrant, and which of those two is cosine going to be negative? Second quadrant. So we gotta go over here and make our reference triangle and realize we're looking for, I guess we can label this one theta, they didn't say x here. And I have to have cosine as -1 over the square root of 2. Definition of cosine? Oh, adjacent over hypotenuse. Adjacent over hypotenuse. Well, we should recognize that one. What's that angle? There we go. Remember, 30, 60, 90 is 1 square root of 3 and 2. No square root of 2 in that one. The 45, 45, 90, 1, 1 square root of 2. So this is a 45-degree angle right here. But again, can't give them that. We have to give this in radians. So we're staying in the PBR, but that means this time we can go all the way over here to name it and come over here. So 45 degrees is what in radians? Pi over 4. So if we have to go this way, what would the label be for that angle? 3 pi over 4. Good. And again, there's lots of math in these, so make sure you're circling or underlining or boxing in your answers there. So you know which one you want for your final answer. Alrighty. Arc cosine of -1/2. Well, we already know what quadrant we're going to be in. Which one? Second. It's got a negative. Okay. Cosine definition again. Adjacent. Okay, so I have to put a -1 here, and then I have to put a 2 at the hypotenuse. Oh, what's the other side then? Square root of 3 makes this angle what? 60. In radians, that would be pi over 3 So now, staying in the PBR from here to here, what would we label? Good. This is 1 pi over 3. We have the 2 pi over 3 to get there. Excellent. Alrighty. Inverse cosine of the cosine of negative 1.1. Huh. Let's do that without a calculator. Okay. Well, let's see. Negative 1.1. That's got to be readable, right? Because there's no angle there. Alrighty. So this would be a negative 3.14 because it's negative pi, and it's been a while. Do you remember the pi over 2? Been too long? 1.57, blah, blah, blah. Okay. So we know negative 1.1 is not going to make it all the way down there. So this would be our negative 1.1. So here's the problem. Is that in the PBR? It's not. So we have to figure out which of our PBR quadrants would give us the same sign as this. What I mean by sign is negative or positive value. So I come down here and I realize, oh, cosine's going to be positive down there. So should I use first or second quadrant? I should use first quadrant. And what's my angle going to have to be to give me the same values? 1.1. Yeah, this was negative 1.1. I need that same opening of my angle to get that. So this is where we replace this with something that's in the PBR. And now, cosine, inverse, and cosine will cancel each other out. And we can put 1.1 in there. So we need to make sure we're in the PBR. So with this one, I don't know. I guess if I were you, and it's been a while since we talked about the pi over 2, I might just grab the calculator real quick and say, okay, where am I looking at here? You know, what is pi divided by 2? And then realize, no, it's not going to go all the way down to negative pi over 2. And then go from there. Alrighty. Tangent already. Okay, so we did our sine, we did our cosine, now we're at tangent. Oh, I remember liking these when we graphed them. Okay. Where were the asymptotes for tangent? Negative pi over 2 and pi over 2. So let's space this out a little bit. Let's make this pi over 4. And we've got pi over 2. Negative pi over 4. And negative pi over 2. So we put asymptotes in there. What else helped us remember how to graph tangent? Negative pi over 4, negative 1. Well, how did you remember that one? What's pi over 4 as degrees? Tangent would be opposite over adjacent, so it would be 1 over 1, and yeah, this would give us a negative 1. What else? 0, 0. I heard somebody very lightly. What else? Pi over 4, 1. And there are asymptotes, and we knew that it was always increasing. Okay, so now comes the time to choose. So we realized we kind of want to take the whole thing. I mean, we would. But really what we need that's what we need. That little window into going from negative 1 to 1. So we're going to go from negative pi over 2 to pi over 2. Opening the door. Sine, cosine, tangent. So this says let's sketch the graph of the inverse of this. And I think, well, I might want to do the inverse asymptotes. I mean, that might be really helpful. I mean, we know that they're going to go from being on the x to being on the y, so maybe we've got a negative pi over 2 down there, and positive pi over 2, and we'll get those on there right away. And then flip those lovely points that we had, which would have been our negative pi over 4, negative 1, 0, 0 is not going to go anywhere. And then we had pi over 4, positive 1. So we reverse all those for inverses. So negative 1, negative pi over 4, 0, 0, 1 pi over 4. And we realize, well, if these are asymptotes, it's going to do this. But again, we're really just going to take the middle chunk. It's kind of bothering me that this is graphing high. Yesterday I had it set correctly, and now it must have got bumped or adjusted. So that's the piece that we would want to take right there. But really for us, it's about what's that PVR? You know, we've got sine, cosine, and now we went back to negative pi over 2. Pi over 2. There's tangent. Well, that means we're right back at it. I mean, we can start going with our inverses. We know what to look for our PVR. And our domain here is going to be from negative 1 to 1. We're going to keep using that. But negative pi over 2. Pi over 2 for that principal value. But now, are we ever going to get to negative pi over 2 and positive pi over 2? Oh man, we have to make a change. We can't have the square brackets. Change is hard. So we're never quite going to get there. So it's just a little change. And it really doesn't change our way of thinking as we're going through this. So we'll be fine. And as it says, nice little summary box here, the inverse tangent function, f of x equals the inverse tangent of x. Oh, look at that. Negative infinity to infinity. So this is different too. Oh, man. How come? You're right on the right track there. Yeah, you're right on the right track. Domain and range flip when you're doing inverses. That's why. And this was going to go up and down forever. Now, what does that mean to us? What it means to us is, when we said before, there were sines and cosines that we couldn't do. We had to put do not exist because they gave us numbers like 1.5. And we know we can't do that. You know, sine and cosine are between negative 1 and 1. Tangent doesn't have that restriction. Tangent can be anything. So that's a big piece. So we still have our principal value range. That's mostly what we're going to be thinking about. But we don't have to watch out for, are they trying to trick us? Sine and cosine, they might try to trick us. Not with tangent. This means that x represents a tangent ratio and f of x represents an acute angle, either positive or negative, in quadrants 1 or 4. So we're back to negative pi over 2 to pi over 2. The inverse tangent function is also called the arctangent. And as I said yesterday, if anybody was gone, the whole problem is when my average to lower level algebra students see that, they want to say, ooh, that's 1 over f. And this was actually the first way that the inverse trig function So that sometimes messes people up. But the -1 right after sine, cosine, or tangent just means it's the inverse. That's what we're looking for, is the inverse. So inverse tangent is the angle between, where are we going for PVR? -pi/2 and pi/2. Whose tangent is x, theta, whatever we have. In this case, it said inverse tangent of x. So its tangent is going to be x. Evaluating inverse trig functions without a calculator. Well, we've heard that before. So we start thinking 30, 60, 90, 45, 45, 90. Find the exact value of the expression without a calculator. And even though I know we've only been doing this for about a day now, when you do D like that, you know what it is? What is it? 45 degrees. You know, it has to be the 45, 45, 90. Now, so this might be one where you say, I'm not going to bother writing all this down. Yeah, I know the PVR's up here. Opposite over adjacent is 1. I know that one. So E, maybe you'd have to draw it, maybe. And realize, hey, if tangent is going to be positive, it's going to be in the first quadrant. And tangent is opposite over adjacent, so that would be the square root of 3/1. So what angle are we looking at there? Give it to me in degrees first. 60, and that's going to be what in radians? pi/3. You got it. Oh, that one looks tougher. First things first. Did it come to us as negative square root of 3/3 in our triangle? No. What did it come to us as? -1 over square root. And this one is negative. So where are we putting our reference triangle? Quadrant. So, opposite over adjacent looks like so. What angle are we talking about there in degrees? What angle? 30 degrees in radians. Pi/6, but I already heard some people say the important part. We can't leave the PVR, so how do we label it? -pi/6. -pi/6. There it is. So yeah, tangent doesn't too bad either. So now, describing the end behavior. All right. So this is going to make us think about tangent a little bit more and inverse tangent. How it is, it's different because we had asymptotes. And because the range of this thing is negative infinity to infinity, when you switch the domain and range to do inverses, it's going to be negative infinity to infinity. But then, describing the end behavior, the limit, as x approaches negative infinity of the inverse tangent of x is, and the limit as x approaches infinity for the inverse tangent of x is. So looking at the graph there, as we go to the left forever, what do we approach? -pi/2. As we go to the right forever, what do we approach? Pi/2. So why didn't they ever have us do this with cosine and sine? Cosine and sine will go on forever. And that was what we talked about. It does not exist. That behavior does not exist. We've got our little PVR that gives us a region that we need to work with for a one-to-one function. But the tangent, it's different. So down here, it says, let's talk about composing trigonometric and inverse trigonometric functions. And we look at this and it says, these are true whenever x is defined in the interval for the ratio. Okay, so they tell us to find the inverse sine. The first thing we should do is say, okay, wait a minute, this has to be a number between -1 and 1, because that's what sine and cosine are defined for. So we think about that. And if it is, bam, sine and inverse sine cancel each other out. And the answer is x, whatever it is. Same thing here. We check to see, are they asking us about a value that's between -1 and 1, because cosine has to be between -1 and 1. If it is, there's our answer right there. And then for tangent, well, that one doesn't have any restrictions. So that means tangent and inverse tangent are always going to cancel each other out. Here's what we need. And if this is not a number between -1 and 1, and this is not a number between -1 and 1, what do we have to write down? It does not exist. So if it's outside the interval, game over. We write does not exist. Which is basically saying can't do it. It does not exist. But not for tangent. Tangent can be anything. Opposite over adjacent. Now, notice that this was sine, cosine, and tangent on the outside. So with math, you always do the inner parentheses first and then work your way out. So this was really important. We can't do it if they give us a value that's not between -1 and 1 for sine and cosine. But down here, we're reversing this. We're saying, okay, find that sine of x. Now go back and tell us where that came from. So these are true whenever x is defined in the PDR of the inverse function. So when we have to take that inverse sine, inverse cosine, inverse tangent as our last step, what we have to do is stay in the PDR, because we just got done showing those little graphs and realizing, okay, if I'm going to do inverses, they have to be in this PDR. So if it's outside the interval, and the last step that you're doing is you're taking that inverse, then you have to make sure that we're in that PDR. So that means you're not done with your work. You can't write does not exist. You have to figure out which interval you need it to be in to get the same trig functions. So if you're outside that PDR, that interval, game on, you got to find the appropriate referencing. You have to find the correct document to give your answer. So that's the difference between the two, because sometimes we look at it and we just say, well, won't they always undo each other? Not necessarily. You have to look a little bit deeper. What's the first thing you have to do? Innermost parentheses, then work your way out. That's just how math has always worked. So on the next page, we see evaluate the following compositions without a calculator. Well, that is always a good thing. Okay. So I see in there that I'm supposed to take the inverse sine of -0.0316. Okay. So that's obviously in radians there. And think for a second, is that going to be in my PDR? 0, -1.5, blah, blah, blah. Is that in the PDR for sine? Oh. I like that. That makes the answer super easy. They undo each other. All right, and B, this is different, because this one says find the sine of pi over 4, and then work your way backwards to find the angle. But is the sine of pi over 4 something we can do? Well, sure it is. You can find the sine of pi over 4. And is that in the correct PDR? Pi over 4 it is. The next one. Sine of 3 pi over 4. Okay, so that's going to be, I'm going to change colors, that's a lot of red. 3 pi over 4. Is that in PBR? No, it's not. Okay, so let's let's see. Positive, 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 negative, negative. Back here we have negative, positive, negative. So which quadrant are we going to have to put this in so we can get the same trig values? 1? Okay, so we put it over here. And what would it have to be, our little theta, to give us the same trig functions? So we're replacing this with something from the PBR. And there it is. Because the last thing we have to do in that one is arc sine. You know what, let's write this up here, because this sometimes, in past years, has really messed people up. Just remember, arc sine is exactly the same thing as inverse. It's exactly the same thing. So if the last thing we're going to do is take the inverse, we have to make sure that it's in the PBR. Alrighty, let's take a look at D. This one has us doing the sine of 13 pi over 10. Okay, so we don't think of it as 13 pi over 10 when we go put it on. What do we think of it as? 1 3/10 pi, so we can figure out where it goes. 1 3/10 pi. Oh, well, that's not a PBR. And we need to be in the PBR because we're supposed to do inverse sine here in a little bit. So let's see. We've got our plus, 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 minus, 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 plus, minus, plus, minus. Where's it going to have to go? Fourth quadrant. So it's going to give us the same angle over here, but in the fourth quadrant. And what do we have to label that? Negative 3 pi over 10. Good. Negative 3 pi over 10. That 10 looks weird. I have to orient this board. It's been laughing all day. Alrighty, E. Inverse sine of 4/3. Wait a minute. Inverse sine of 4/3. What's wrong with that? Yeah, that can't happen. This number is bigger than 1. Remember, for us to take those inverses, it's got to be between -1 and 1. So what do we put down? Does not exist. Can't do it. It was a trick question. 4/3 is bigger than 1. So we can't do the inverse then. Okay. Notice all of these were about sine. So our PBR was negative pi over 2, pi over 2. Now we've got to switch gears. And we have to think a little differently. As soon as I check this little, we get a few more done here. We can get all these cosine ones done. So cosine of 3 pi over 4. Did you have to make the drawing, or did you just want it out? 3 pi over 4, which quadrant are you going to be in? Second quadrant, is that an opaque quadrant for cosine? So let's answer this. 3 pi over 4, exactly. So whether or not you make the drawing or not, you realize, oh, it's the second quadrant, that's perfectly fine with cosine, so 3 pi over 4. Uh-oh. Graph 7 pi over 6, what should we think of it as? 1 and 7, 6. 1 and 1/6 pi. Is that the PBR? It's not. Okay. So positive, 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 negative, 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 negative. Uh-oh. We have negative, don't we, for cosine. So which quadrant should we put that in? Second quadrant. Because here's our PBR right up here. Okay, so then we have to figure out what the name of that angle is going to be. This was 1 and 1 pi over 6. But we have to stay in the PBR to label it. So what would it be labeled? 5 pi over 6. Good. It's like we're replacing this. Alrighty. Square root of 2 over 2. Cosine of square root of 2 over 2. Can we do that? Square root of 2 over 2? Something between negative 1 and 1? Oh, well, then we're done. We're going to undo each other. Between negative 1 and 1. Because this one said cosine first and then inverse cosine. This one says inverse cosine first. I don't like the way they wrote this. They're messing with our heads. So I think about my PVR and where that placement would be to get a negative 1 half. What quadrant would we have to put this in order to get a negative 1? So do we need to do anything else with this problem? What's our answer? Negative 0.5. Yeah, we probably better put it the way they gave it to us. It's in our PVR. It's all good. They're going to undo each other. It's in the PVR. Alrighty, let's look at E. Uh-oh. We can't use 23 pi over 7. We know that. Yep. For D? Yeah. When we know that we have an inverse cosine for negative 1 half, we think, well, we're going to be able to do that. We've got positive cosine here, negative cosine here. If we put our angle in second quadrant, we're good because that's in our PVR. And as long as it's in the PVR, these two are going to cancel each other out. So we'll be fine. The one thing that people get messed up with is the innermost parentheses goes first and then go to the outside. So as long as we can do these first and know that this is in the PVR, then the other one is just going to make this. But if it's not in the PVR, you have to put it somewhere first where it will be in the PVR in order to value the find our answer. Yeah.
So how come C is at pi over 4? Because then it's really 1 over square root of 2, which is like a 45 degree. And then
You're thinking reverse though. See, Hannah, you were just doing inverse cosine in your head first, and then cosine. That's not what this says. It says cosine of pi over 2. So if you punch that in your calculator, you're going to see the cosine of the square root of 2 over 2, which is the ratio of the two sides. This is where we work backwards to get the angle. But because we're already in the PVR, these two are going to cancel each other out. You just have to make sure the square root of 2 over 2 is in the PVR. Alrighty, inverse cosine of the cosine of 23 pi over 7. Pretty obviously not the PVR, right? Or at least not something we could immediately see as the PVR. The name is definitely not the PVR. So 7 goes into 23 how many times? 3 with the remainder how many? So 3 and 2/7. 1, 2, 3, and 2/7 more. Yeah, I know that's not visually accurate there. Are we in the PVR? We are not. So, what quadrant do we need to place that in so we'll be in the PVR? Second, because this is supposed to be negative. But cosine, we have to start naming from over there at 0. So if that's 2 pi over 7, what name do we give it? 5 pi over 7. So we didn't get to the inverse tangent ones, but that's okay. That'd be a good place for us to start. Yeah, and you know what? I'm a little bit worried that we might not get through everything tomorrow, given that we have our 2-hour early release. So I might have to just videotape the rest of it to make sure we're all caught up for next week. But we'll see how it goes. You know, Usually, once you've done several of these, you kind of get in the rhythm, and it might go faster than I think it will tomorrow. There it is. Try not to hurt your eyes. Your phone may need to adjust. Try not to overthink. That's going to be the key with these. Try not to overthink. Don't look for things that are